if you want to get some homework questions posted to the chat, we can start there. Okay, Math 10. Section 4, and the date is the 21st. There's homework number 3 due tonight on XYZ. Okay, then I see the question. We'll definitely get to the questions. I gave more time on quiz number 3. So the goal, is to practice. There's no rush in doing the practice. I saw only a few people had tried the quiz, so just to give everyone else time, there's another week. So quiz 3 has been has a new due date of the 28th, and we'll do quiz 4 after that. So just continue to work on this assignment. We'll make a new assignment later in Canvas. Alrighty, so I have a question to do. A graph. How do you graph a line when you've solved for slope? Well, I can definitely go over graphing lines, and I already have an example for solving for the equation of a line. And then I made a few notes to help with quiz 3. And then the plan after that is to do practice problems from the chapter that homework number 4 is about, which is still graphing lines. It's just kind of like applied problems. Okay, so let's try graphing. Let me see. There's also some notes that I kind of skipped last week. And I'll just go ahead and write them up for you. Not quite sure if this will answer the question I have, but let's at least do these notes and we'll see if we need to do more examples or something. I want to graph. Slope intercept form. And that's y equals mx plus b. That form. Your y-intercept is 0b, and that's, you want to plot that point as your starting place. Start by plotting the point, or I guess say graphing the point. It's actually a specific point. It's called the y-intercept. X equals 0, y equals b. And we'll practice a couple of these. So you start here, and then you go to your slope. Just in case your slope isn't written as a fraction, let's say if you need to, you can write your slope over 1. That way you have a numerator and a denominator. Anyway. Okay, once you've got this point down, start from there. And you use the slope to go up the value in the numerator and to the right the value in the denominator. Okay, the only other thing is if it's a negative slope, you go down the value in the numerator, but you still go to the right, the number in the denominator. And then still to the right. We're going to do examples, but just as a side note, I've mentioned before, another way to graph a line is to find one point of your line and find another point on the line and then draw a straight line through those 2 points. Okay, let's try this way though. We're going to graph y equals -3/4 x plus 2. We're going to start here at the point 0, 2, your y-intercept. So on the y-axis up 2. Let's make some more units. Okay, from here, we are going to go a negative slope. So down 3, right 4. 1, 2, 3, over 1, 2, 1, 2, 3, 4. That point would be 4, -1. And we could do this again. You'd go down 3 more and then over 4 again to the right. But I just need 2 dots and then connect them with a straight line, and that's the graph that I'm looking for. Okay, this time we're graphing y equals 1/2 x plus 5. We are going to go to 5 on the y-axis, or plot the point 0, 5. We're going up 1 and to the right 2. Up 1, over right 2. 1 over 2. I do it again, up 1 over 2. Maybe a little further over. Okay, and then straight. One more of these, and then I want to help with quiz number 3. It's y equals 4x minus 3. Let's make some units first. Okay, so we are going to the y-axis and finding -3. The y-intercept is 0 for x and -3 for y. Then you want a numerator and a denominator. So I can take any number and I can put it over 1. Oops. So I want to go up 4 and right 1. And then we'll draw. Okay. For quiz number 3, the first question asks you to find the equation of a line, and you know 2 points on the line. So I'm going to pick 2 random points, and we'll find that equation for that line. I already kind of peeked at a few people's responses, and I just want to mention that if you find the slope, you have to keep working to still find the whole equation of the line. The slope is just a piece of the equation. But it is good that everyone correctly found the correct slope. We'll not put help, we'll put notes. Okay, actually, before we jump into this, are there any other homework questions? All right, let's try an equation of a line that passes through 2, 5. First point is 2, 5. The other point is negative 8, 6. I like to use the general equation of y equals mx plus b. And then you find m, and then you still need to find b. And then you need to put that all together as y equals some number times x plus some other number, depending on the points that you're given. Okay. Okay, let's see. Got a question. Oh, I like it, for me, like if it's on a test, I like it left as a fraction. So someone asked if you have, if you do want it as a decimal or a fraction. I'd say fraction, but try to simplify your fraction. That's the only comment I've got. Okay. So is your difference in y values, y1 minus y2. Divide by difference in x values and match up your subscript. So like x1 subtract x2. This is x1 and this is y1. Here's x2 and that's going to be y2. Messy. What's the first part? We want this guy 5 minus 6. Over this one 2. Subtract negative 8. This is negative 1 over 2 plus 8. And I've kind of mentioned before that if you've got a negative sign in the numerator, you can also write it out front. You could write it in the denominator. As long as there's one of these as part of your number, it's a negative number. So I'm going to bring it kind of to the front, and then there's 1 over 10. So we're getting closer to the equation of the line. I have y equals negative 10x plus b. Negative 1 over 10, that's what it is. Times. And now you need to find b. Use one of the points that you're given. I think it was the 0.25. Yeah, I picked the first point. So 2 for your x value, 5 is your y value. And we're putting it into what we have so far. So 5 is over here. I've got negative 1/10 times 2 on the other side. And then we're going to solve for b. Five is equal to negative 2 over 10, and I'm going to factor 10. It's 2 times 5. And then we're adding b. 2 over 2 simplifies down to 1. And so 5 equals negative 1/5 plus b. I'm going to add 1/5 to each side. Plus 1/5 equals b. I just want to put those numbers together and then I'll have my value for b. But I need a common denominator. So I'm going to take 5, I'm going to put it over 1, and then multiply 5 over 1 by 5 over 5. And let's go over here. 25/5 plus 1/5 is equal to b. Over 5 equals c. And I would leave it like that, like instead of a decimal number. And the final answer is y equals this negative 10x plus 26/5. Okay, I am going to move on, but if you need any more help with questions like this, please visit office hour. I've had a few people visit already, and it's been really fun to meet someone new. It's been a while just hanging out at home. Okay, I want to go over horizontal lines and vertical lines and how to quickly find an equation of either one. Okay, if it's asking for a horizontal line, it looks like y equals some number. So it's y equal to a number. Vertical lines have a form that looks like x equals some kind of number. So if you have a problem that says, find the horizontal line that goes through 3, -2. We'll use this form, and we'll use the point that they give us. This is the x coordinate, this is your y coordinate, and it's a horizontal line. So you want to go with that y value, and the line is y equals -2. Talked about these graphs before, but just going through it again. This is the x-axis, here's your y-axis. Okay. Let's plot this point first. We're going over 3, down 2. And then when you have a line like this, y equals -2, and x isn't mentioned, it means x can be any number. So you could have x equals +10, and then y equals -2. That is a point on this kind of line. So it can go up any number for y. Sorry, I can use any number for x. So x is left and right. So you can go this way and that way, but y has to be -2. So you can go -3 for x and down 2 for y. That would be here. You could go 4 for x and down 2 for y. That is my horizontal line. Cool. All right, let's do a vertical line. Same point. I think passes works, like passes through. Same point, it was 3, -2. Okay, for the vertical lines, that's when you have x equals some number. So use the x value from your point. This one's x, this one's y, and we want to go with x equals 3. And when you have this as the equation of a line, it means y can be any number, but x must equal 3. So we're going to do the graph. Put some units on it. Cool. First, I'm going to put the point down. The point 3, -2. This way, down to. And then I'm going to just check that I have the right equation for the line. So here I can let y be any number. I'm going to let y equal -1, and I have to have x equal to 3. So if I go -1, no, x equals 3, y would be -1. That'd be like right here. And then I'm going to draw a line through those 2 points. I did find a vertical line that's going through the point, the first one we did, 3, -2. So this was the line x equals 3. Okay, last one for quiz number 3 is I'm going to show you an example about x and y intercepts, and then we're going to do problems for your next homework. this is of, let's say like if y equals I picked 3x minus 4. Okay, if you want your x-intercept, you put y equal to 0. So if there's a 0 right here, it'll be equal to 3x minus 4. And we'd have to solve for x. Okay, so we add 4 to each side. Then divide both sides by 3. So on this side, there's just x. Over here, it's equal to 4/3. We're going to write our answer as a point. So the x-intercept is 4/3, 0. To get your y-intercept, you put x equal to 0. Still using this equation. So I've got y equal to 3 times 0 minus 4. Okay, so this is y equal to 0 minus 4, which means y equals -4. And then we're going to write the intercept as a point. So the y-intercept is 0, -4. Intercept, y-intercept. Okay. All right, so I'm going to go ahead and show you some problems from the book. And what I've done is made a PDF of the problem and the answers, but I'm still going to I'll share the screen with you, but don't worry about writing the problem down. It'll be posted to the module for, I think we're in week 3. Actually, we're in week 4. Okay, here are, I think, 4 examples. Thanks for being patient. Still getting used to Zoom. Also, as a side note, I'm really excited. I'm going to have a new setup and a couple of whiteboards on a wall for the first time ever since teaching in a classroom. Okay, I think I got it. All right, so I'll be posting this PDF to Canvas at some point today. Let's see if I can get this right. There we go. Okay, so we're starting over in section 3.2 with number 87. If I can highlight this. So it's a similar but different problem to one of your homework problems. You have an equation v equals negative 45,000 t plus 600,000 can be used to find the value v of a small crane at the end of t years. We're going to work on part A. What is the value of the crane at the end of 5 years? So we're going to use t equals 5. Right, so I have kind of parts of the problem that you can at least write down, and then we'll work through each of these. Okay, these practice problems are from chapter 3. They're kind of the problems at the very end of the of each section in that chapter. So just as a reminder, you have an ebook in your XYZ homework program. And I use the ebook a lot to get like examples, and there's a lot of practice problems and explanations for those problems in that book. For number 87, V equals negative 45,000 T plus 600,000. We're going to put this actually, just to note that they tell you that V is the value and T is the time. The value is in dollars. And the time is in years. Okay, part A. What is the value at the end of 5 years? So what is the value is asking you to solve for V out of that equation when T equals 5. Okay, V would equal negative 45,000 times 5 plus 600,000. And let's see, I got $375,000. Okay, so I'm only going to get that picture up of the problems if we need to kind of get info from the problem or use a graph in the problem. But for the most part, I'm just going to stick to working on the whiteboard. So part B asks, when is the crane worth $330,000? Okay, when is asking you to solve for that time, t. And the worth is 330,000. That makes that v. We're going to substitute this number in for v. Okay, so this is, let's do it over here. We're starting to solve. And the first step is to let v be equal to that number. Okay, and then we use the equation, and I have it in my notes. It's v equals negative 45,000 t and then add 600,000. We're going to have this right here substituted in. And then we're going to need to solve for t. The same process we've been practicing, it's just larger numbers. So we're going to subtract 600,000 from both sides. This side, I've still got my negative 45,000 t. And then on this side, it's 270, negative 270,000. And of course, if you see any mistakes or think that something's gone wrong, please let me know. Okay, to solve for t, we need to divide each side by negative 45,000. So I'll have my t on this side equal to some positive number, and it's going to be 6. And t was in years, so the machine is worth this much after 6 years. Okay, part C asks, will the crane be worth $150,000 after 9 years? $150,000. There's a few ways to solve it. One way is just to put in this, for this value and solve and see if there's a corresponding number that's matching, which is how I'm going to do it. I guess you could also put in both values and see if you get a true statement, but we're going to put in t equals 9. So at 9 years, I want to know what the value is. If it is 150,000, then I'll say yes. If it's some other number, then we're going to say no. Okay, let's see. Okay, the formula is for the value and it's negative 45,000. We're putting in 9 for the time t. And then it was add 600. And then I worked on this earlier, but let me know if you get a different number. I got 195,000. So I put nope. After 9 years, the crane is worth this much. $195,000. Last part of this problem is how much did the crane cost? Part D. So the how much is finding that value V, and it's when you first purchased it, so at time t equals 0, right at the beginning. So that's just a like side note, I guess, is sometimes in a problem it'll say like when the first thing happened, or like when, how do I say? I guess using time t equals 0 is when you start something, or when something first begins. Okay, let's put that into our equation. So we've got v equal to negative 45,000 times 0 plus 600,000. Okay, so the value at time t equals 0 is 600,000. This is all going to be 0. All right, there's another set of examples from the next section. I'm going to show you the problem and then we'll come back to the whiteboard to work it out. Okay, we're here in section 3.3. highlight. Okay, we're on number 53. So again, there's problems like this in homework number 4. Here we have Maggie, who has a job working in an office for $10 an hour, and another job driving a tractor that pays $12 an hour. And she works both jobs to earn $480 in 1 week. First thing we'll do is write an equation for specific variables. X will be number of hours worked for $10 per hour. They want Y to be the hours worked for $12 per hour. And then we'll use this other info up here to put an equation together. It's section 3.3. Number 53. Okay, Maggie works at an office for $10 per hour. And driving a tractor for $12 per hour. She earns, we'll just put, and earns $480 in 1 week. Okay, in part A, they do sort of help you or direct you in how to set up the equation. They tell you to have the variable X, and X needs to be equal to the number of hours that she works for $10 per hour. I should set a timer. I don't want to keep you guys over time. Let's see. Cool. We're all set. So we're here. This first. I told you to have Y equal this other number of hours that she worked, $12 per hour. Okay, for our equation, we're going to take the number of hours worked plus the amount or the value, how do you say? Number of hours worked multiplied with like the amount made for those hours worked, add it with the number of hours worked at the other job and how much you make per hour there. And those two together is that total of $480 in 1 week. So we want to take 10x, add 12y, and have it equal to 480. And that's your equation. Part B asks to find x and y intercepts. Okay, that's the end of the question. Starting to solve the problem. X-intercept is when y equals 0. Okay, so we're here with 10x plus 12 times 0 equal to 480. Okay, 12 times 0 is 0. So what's left is 10x equal to 480. I'm going to divide both sides by 10. And then x is equal to 48. I like to write my intercepts as points. So the first part is your x value, 48, followed by the y value, which we put equal to 0. That was the x-intercept. For your y-intercept, you have to let x equal 0. Okay, so we're here. I'm going to go back to my original. We've got 10 times 0 plus 12y equals 480. So 12y equal to 480. Divide each side by 12 and solve for y. Okay, this side we've got y. On this side, 480 divided by 12 turned out to be 40. And we're going to write it as a point with x first, which we put equal to 0, and y after, which we found out would be 40. Okay, the next part is to graph the equation in the first quadrant. It's part C. what I'm going to do, well, first we're going to find the first quadrant, and then we're going to put this intercepts down and the other intercepts down and use those 2 points to draw the line. So we have this y-axis, here's an x-axis. Let's mark some units. Oh, well, we'll see how we label this once we check out the points we need to graph. I'm going to graph 48, 0. 48 for x, 0 for y. So let's go with 10, 20, 30, 40, 50. And just a bit closer to 50, we'll call that 48. And I'm also going to graph 0, 40. So 0 for x up 10, 20, 30, 40. This corner is the first quadrant. It was quadrant 1. This one's quadrant 2. Quadrant, well, actually, it's Roman numeral. This has to be like this kind of 2. Quadrant 3. Quadrant 4. So over here in this top right corner, and we want to connect those dots, but just don't go over into that quadrant and don't go down into this bottom one either. We're just going to stick from here over to there, and that's it. Okay, so we're going to look up the next question. It looks weird, but once we interpret what it means, it's not that difficult to actually do. Okay, so we're still on number 53. We wrote an equation. We found x, y intercepts. We put the graph in the first quadrant, and now we're at part D. I'm actually not going to use the graph. I want to find out how many hours she worked at $12 per hour if she worked 36 hours at $10 per hour. So if you remember your variables, x was the number of hours worked at $10 per hour, y is the number of hours worked at $12 per hour. So this question is asking, if x equals 36, what is y? Okay, so let's just, I'm going to write down this info and we'll come back and kind of translate it and solve it. How many hours she worked at $12? Okay, here we go. So I kind of paraphrased the question. And then if you know or you're told that she worked 36 hours at $10 per hour. So just a reminder, recall X was the number hours worked at $10 per hour. So you're told to put x equal to 36. And find the number of hours worked at $12 an hour, which we called that number y. So in our equation, which was 10x plus 12y equals 480, putting in x equals 36. Okay, so I've got 360 plus 12y equals 480. We're going to subtract 360 from both sides. 12y equal to, let's see, I've got, let's just work this out. So here's a 0, 6, 7, 8, and difference of 1. And divide both sides by 12. Okay, y equals 10. 12 is, 120 is 12 times 10. And it's over 12. And the 12 over 12 is going to reduce down to 1, which leaves 10. As a full sentence, you would say she worked 10 hours at $12 per hour. Okay, last part is similar but different. For E, it asks,